All right, stat students, we are starting our next unit today just with an intro lesson. This one isn't going to be too long. We're just working through a worksheet, and we'll have a longer lesson on the next video. But let's go ahead and get into it. So you have this sheet in front of you. This is our Unit 7. Actually, no, Unit 8, Chapter 9, and we only have 2 more units after this. But we're introducing the idea of something called a hypothesis test, okay, significance testing, which if you really understood confidence intervals, this should go pretty well also. But we're starting with this scenario here. We have a teacher named Miss Gallus. She claims that she's an 80% free throw shooter. To prove her skill, she shoots 50 free throws and makes 32 shots. Is Miss Gallus exaggerating about her free throw skills? So we're going to start by reviewing some of these terms here. And in our last chapter, what we did with confidence intervals is what we were trying to figure out. What is her true ability? What would her true ability be? We'd make a confidence interval for that. But in this example, we're just trying to say, okay, does this data 32 out of 50, does that make it plausible that is her free throw ability, or is she exaggerating a little bit? Okay, so we're going to start by filling in some of these blanks here. We're going to go back to sort of some of these basic terms, the population, parameter, sample, and statistic. In our Chapter 7 test, you had to identify parameters and statistics. We'll go ahead and fill this in right now, and you can just ride along with me on this. So the population would be all of her free throws. It's just her total ability, every free throw that she would take. So that's what we're going to write into this first blank. Okay, so I've got that in there. That's all I put Miss G's free throws. Okay. And what we're trying to estimate is we're trying to get a proportion, her true proportion of her ability to shoot free throws. So this will be P, which is equal to her true portion made. Skip ahead with this. Okay. Really, that's her ability to shoot. That's really what we're looking at here, free throw ability. So in order to estimate or help us, we're not estimating, we're trying to sort of test a claim here. That's what we're learning about here. We take the sample. So the sample are that's the 50 free throws that she took. And the statistic would be we're taking the 32 out of the 50 shots that she took. So what our statistic is actually a p hat here. So this is proportion. This is p hats. And so that would be 32 out of 50, which if we grab out our calculator, we have 32 divided by 50. So that's 0.64. Okay. So 0.64. And so when we see this statistic here, and we look at that and we compare it to the claim of 80%, we have to be thinking, oh yeah, she's definitely exaggerating, right? It seems like she is exaggerating. But there's 2 explanations for why she only made 32 out of 50 shots. So the first one is that she is I'll say an 80%, you can write this as I'm writing this, an 80% free throw shooter, and just had bad luck, right? So that's one option. Okay. And if we were her friend, maybe we would say something like this, or, if you wanted to defend yourself, you say, oh, I just had bad luck. We hear that all the time. Somebody had a bad set of 50 free throws, right? So that's one option, right? The truth is she's an 80% shooter, just had bad luck. Or the second option is she is not an 80% free throw shooter, and that's it. Okay, those are the 2 choices that we get in this example. Okay, so to help us with this, you'll notice here it says to test her claim. We're going to assume number one, she's an 80% free throw shooter. And she just had bad luck. That's what we're going to assume. We're going to assume that she just had bad luck with the shots. Okay, and we're going to examine the chance. Like, what would it, if it's bad luck, what is the chance that that would happen? Okay, so what we're going to do is we're kind of going back to chapter 7 with the sampling distribution. Over here on the left or the right side of the video, we're back on StatKey. This is the website we use to do our song project. Now, we did sampling distribution for means with the Taylor Swift song and all of your songs, but we're going to look at proportion here because we're talking about proportions. So let's pretend that our original population over here, I'll zoom in on all of this to try to show it. So the original population, we have the wrong proportion there. Let's pretend that she is in fact an 80% free throw shooter. Okay. And that's what should happen. And we're going to take samples of size 50. You'll notice on the actual sheet that you have, it says use the spinner to simulate 50 free throws by an 80% free throw shooter by spinning 50 times. We're not going to do that. We are going to we're going to use StatKey to help us with this. Okay. So using the spinner provided to simulate 50 free throw shots. Okay, so we're going to have this actually on StatKey simulate this happening once. Okay, so in this population, we have an 80% free throw shooter. So we're going to simulate 50 trials with 80% success rate. So we're going to generate one sample. There it is. So this sample gave us a 0.92. So I'm going to write that in there. We had, let's do 46 out of 50 for a simulation. That's 0.92. Okay. Now it says repeat this for another sample of 50 spins. Calculate the sample proportion. I assume this worksheet has some sort of application, but what we're going to do is I'm just going to keep generating these. So on this one, this next one was 0.82. Okay, so that's 41. So 41 was the next one. So 41 out of 50, which is 0.82. So far, we have not yet had a random sample of 0.64 actually happen yet. Okay. Now it says add the sample proportions to the dot plot on the board. Well, I'm just making mine here on the StatKey, which, by the way, I'm probably going to save my notes here and upload these somewhere. I'll probably put these in an email to you guys as you're going through this, so that you can see what we filled in, just so we have it. Each person in your group add 2 dots to the board. We're going to actually do this instead. I'm going to simulate. We have 2 samples so far, so we're actually going to simulate. Let's do 100 samples. Okay, that's what we're going to do. I guess technically it'll be 102, but let's do this 102 times. So I have 102 samples here. Of course, it makes our mean and our standard error right there. We learned about all of these things, but this is what our sampling distribution would actually look like. So I'm going to take this and we're going to snip this into here. So I've put that in here now into my sheet. You don't have to worry about like drawing this. It says to draw it, but we get an image of what this looks like. So it says, what does each dot represent inside of this dot plot over here on the left side that we just created? What does each dot represent over here? So each dot represents a random sample of 50 trials where each trial has a 80% success rate. Well, actually, let me rephrase this. So it's not that. So it's a random sample of 50 trials where each trial has an 80% success rate. But we're going to say it this way. So a random sample of 50 trials where we count the number of successes where each trial as an 80% success rate. Okay. Each dot is a sample proportion. So that's what that is. Each one of these are all p-hats, sort of like what we did with the Reese's Pieces machine. This is just simulating her shooting the free throws. Okay. Now, based on the simulation results for what I've done here, how likely is it for an 80% shooter to make less than 64% or less when they shoot, or when she shoots 50 free throws? Well, we didn't have it ever happen. So out of the 102 trials, how many times did that occur? It didn't happen at all. Okay. So really anything below this, we're going to say this was 0 out of 102 samples had 64% or less, which 0 divided by 102 equals 0%. This is not just bad luck, it seems like. It doesn't just seem like that this option really is plausible, because if it was bad luck, we would expect it to be closer in this range here. There are no samples in our simulation that had 64% or anything lower than 66%. Okay. So based on our answer to question 7, does the observed p-hat of 0.64 result give convincing evidence that Ms. Gallus is exaggerating? Or is it plausible that an 80% shooter can have performance this poor by chance alone? Okay. Let me actually move this sheet. So let me actually make this full screen again. So that's what we wrote for number 7. So on number 8, it says, okay, so based on this, is it plausible that she's exaggerating? Say yes. We have convincing evidence that that she is exaggerating, because there is only a 0% chance that that we'll say an 80% shooter makes only 32 out of 50 free throws. And really we could just say there's a 0% chance that an 80%. So in a simulation, if they truly are an 80% shooter, then so far we said there's no chance that they would shoot this poorly. So it does seem like this is an exaggeration on her part. Okay. So let's check out the back of this, and we'll talk about setting up hypotheses in another lesson, but we can probably get this. Actually, we'll just stop here, since this is sort of like just an intro of the concept of it. We'll just do the front part of this, and we'll come back to the back part tomorrow. So just be prepared to have a lesson over just a little bit more like notes in our notebooks over this stuff. I just wanted to have a brief lesson today to close things out for the day, since we took our test to start class.